Welcome back to V Learners YouTube channel. Here I will be covering the concept of computer organization that comes under VTU third sem. Before going into the concept, please do subscribe to my channel, like, share to your friends. And in my previous video, I have posted about the performance and processor clock, that is nothing but the clock rate. If you all want the video, I will provide the video's link in the description box. Please go through that video and come back to this video, because so that you will know the basics, so that it will be easy for you all to understand this concept. So in this video I will be teaching you all about the basic performance equation and about the performance measurement. You all know what is performance and why the things that will affect the performance we saw in the previous video, right? The three things that will affect the performance of a computer is the instruction set, hardware and software. I explained you all in a easy way. Please go through that video and don't go through all this definition and get afraid that it is difficult concept to remember, but actually it is very easy to remember all this concept. I will explain you all in simple way that you all will get to know this concept very easily. So first, there are three alphabets that you have to remember here. One is T, another N, S and R. If you all remember this four alphabet, the basic performance equation concept will be easy for you all. So you all know that in order to increase the performance of the performance of the computer, to get accurate good performance of the computer, you need to reduce the time needed to execute and program, right? How can you reduce the time that is required to execute a program? So we have an equation for that. With that we can easily reduce the time required and increase the performance. The concept is very simple. There are four alphabets: T, N, S, T and SR. So what the T stands for? T obviously stands for time, and we will see what time it is. Obviously, it will be the time required to execute an instruction or program. Sorry, it will be the time required to execute a program. N is here I have provided. See, processor time required to execute a program, and N stands for actual number of instruction execution. If you take a program, there will it will not consist of only one instruction or two instruction. A program means there will be a number of around 500, 1000, all that lines of instruction depends upon the type of program. A program usually consists of number of instruction. So how many number of instruction a program usually consists, that is N. Okay, I hope that this concept is becoming easy for you all, and with that I will proceed further. So S, average number of basic steps needed to execute one instruction. In my previous video, you all remember that I have told you all that instruction will be divided into basic steps. For example, let us take some program. For an example, I will take the sum of addition that you all do for in C or C++, any language. You all will have a main program and a function that will add and send back the result to the main program. The main program will display the message, right? So you all divide the program into steps like functions. Subtraction by one function, addition by some function, you all divide that, no? Similarly, the instructions will be divided into basic steps. So average number of basic step needed to execute one instruction. So the instruction will be divided into, if you all take for example, let me show. If this is like my program has somewhere around for example, we'll consider some 6 lines or something. My program has around some 6 lines. Okay, yeah, what I will do is that I will divide this into three. So three by like three lines of instruction into one basic step, three lines of instruction into another basic steps. So I have two basic steps here. So average of this two is one. So in one, average of this is one, right? I have two basic steps. These two basic steps, in these two basic steps, the one machine instruction will be executed simultaneously. That is what is S. I hope you all understood. Next is clock rate in cycles per second. Cycles per second is also called hertz. You all can easily remember, like clock rate in, if you all don't remember cycles per second, you all can also write clock rate. Clock rate in hertz. You all know about the clock rate. I have explained that in the previous video. So let's see what equation we can get from all these terms and see how we can increase the performance of the computer. So I have intentionally not given the equation here. So the equation that will increase the performance is T is equals to N into S that is base average number of basic steps by r, that is clock rate. So let's see. Equation 1 is referred as basic performance equation. That is, this equation, if you all write, you all can get 1 mark, like 1.5 mark if they ask about the basic performance equation. According to VTU, they will ask this five concept that I've explained. So far, I've explained about bus structure, performance, clock rate. In this video, I'm explaining basic performance equation and performance measurement. These 5 terms they will ask like this: explain the following terms, and each concept will be given 2 marks. So if they ask this, you all can write this equation and tell what n stands for, what s stands for, what r stands for, and you all can get 1 mark at least. So let's see what this equation explains us. So this is what called as basic performance equation, which is called t is equals to n into s by r. So when t has to be increased, the divisor r has to be decreased, right? So in order, when we will increase the performance of the computer, when the computer performance will be increased, when the time required to execute the program is reduced, then only it will be increased, right? So to reduce the value of t, what we will do, we will increase the clock rate. I hope you'll understood still here. Main motive is just simple, don't get confused. First, performance increase ಆಗ್ಬೇಕಂದ್ರೆ what we have to do, we have to reduce the time. To reduce the time, we increase the clock rate. So to increase the clock rate, we have two possible ways. So we will see what are those two possible ways to increase the clock rate. One is to improve the IC technology. If there is improvement in the integrated circuit, no, logic circuit will work faster. That is the concept here. Logic circuit will work faster. If logic circuit work faster, this will reduce the time needed to compute the basic step. No, obviously the thing will happen like this only. If something is working faster, if some mission or something that you're working with, if it works faster, your time gets saved. If your time gets saved, obviously eventually the performance of your work will also increase. You're doing some work with your laptop, if it is going slow, you will not be able to complete the work on time, and obviously your performance will also go down. That is what they are telling here. If the logic circuits are faster, IC technology, if it improves, the logic circuit will become faster. If the logic circuit becomes faster, time will get reduced to compute the basic step. Now let's see the next point. This allows the clock period to be reduced and the clock rate to be increased. What they are telling is that time if it reduce, no, time for what it is reducing the time to compute the basic step. I initially told you I made some line and I divided the program into basic steps. Some 6 lines was there. I divided into 3 lines code into 2 parts, and that is called to compute the basic step. If the to compute the basic step, time will be reduced. And I have told in processor clock, this both are uh, inversely proportional. The length of clock cycle is inversely proportional to the clock rate, or vice versa. So the same thing happened here. So we will see the next point what it is. Reducing the amount of processing done in one basic step also reduces the clock period. In simple term, I will explain you all. Don't get confused with all these definitions that they have given here. Reducing the amount of processing done. So I have number of instruction, like around, assume I have underlines of code for a program, and I'm taking more time in dividing them only. What happens, more time is spent there, and obviously my performance goes down, right? So if the processing of basic stuff, if I'm dividing the instructions, the program in faster, then what happens, the clock period will reduce. As I told, the clock period, that is p, and clock rate are inversely proportional. If p is reduced, r will be increased. Our motive is to increase the r. Our main motive is to increase the clock rate. Clock period will be reduced. How it will reduce? Process, if I do the processing of dividing the steps, my clock period will be reduced. Time will obviously come down, and so that my clock rate will increase. If my clock rate increase, my time period will decrease according to this equation. Fine. So I have also explained you all about the cache in my previous lectures, that if cache is there, the movement between the processor and main memory will be reduced, so that time is reduced, so that there is a performance gain expected from the faster use of technology. You understood? In presence of cache, percentage of access to main memory is small. There is no need for me to go come from the main memory to the processor, and my time is reduced. I save the time there. If I save the time, my performance goes high. And from this all happens from the use of faster technology. The value of t will be reduced by same factor as r is increased. This is nothing. You all just remember this line, like when r reduces, no, by the same factor this by the same factor, whenever R reduces, this S and N and S will remain unaffected. If R is reducing, it has nothing to do with this N and S. That is what is given in the last point. I hope this you all understood. So let's go for performance measurement. Performance measurement in simple term, I will explain you all. Don't get confused here. I have a benchmark. Benchmark is a standard task. So you all have this entrance exam to get into any reputed college, right? Similarly, a computer has something called benchmark. That is a standard task to see how well the processor operates. That is what is given in the first to to see whether the computer is perfect. It works in all ways. To see how the processor operates, there is something called benchmark is a standard task. Just remember, it is like an entrance exam for the computer, just as we have an entrance exam to get into any reputed college. So performance measurement is the time taken by the computer to execute a given benchmark. So performance measurement is the concept that we are going to read, right? So what is performance measurement? Time taken by the computer to execute given benchmark. How well the computer performs this benchmark, that is the entrance exam, how well does it do, in what time does it do, is the performance measurement. In simple terms, I'm explaining y'all. Spec, this is very important. If you all write about spec itself, you all will get mark. Selects and publishes the standard program along with the test result for different application. It is a corporation, like system performance evaluation corporation. It is a company type of thing that will select and publish standard programs. Like you all have key points for the entrance exam, right? Whatever entrance exam you all write, there will be for this question you will have an key answer. That is what for the standard program they will have the result also for different application. For example, let take case set neat or different entrance exam, there will be test result answer keys for that. That will be with this company called spec. Rating is given by running time on reference computer and running time on the computer under test. So there will be some particular computer that has passed all this test. Okay, that is reference computer. Whatever time is there in that computer, how long that the reference computer take, that time divided by the time taken by the computer under test, that the computer that we are testing, right, divided by that will give you the spec rating. If spec rating is 50, we will tell that the computer under test is 50 times faster than the reference computer. Suppose like this computer has somewhere around 500 milliseconds, and running computer time, this newly manufactured computer has somewhere around 50 500 millisecond, and this takes 50 milliseconds for the for some particular application to execute. What it will happen, it will be around 10 millisecond will be the answer. So we will tell that computer under test will be 10 times faster than the reference computer. This is how we will calculate the spec rating. The test is repeated for all program in the spec suite, then the geometric mean of the result is computed. For one particular application we will get 10 millisecond, for another particular application by the computer tested will be somewhere around 20 millisecond. All those tests for different application, or the test will be conducted. For example, take physics, chemistry, and biology, where the different tests that you all wrote in your entrance exam, right? Similarly, there will be for different application this test will happen on the computer newly produced, and the geometric mean of the result is computer. The geometric mean will be computer. Rating of program of I in spec I is equals to rating for program I in the suit. Overall spec rating for the computer is given by this equation, which is spec rating is equals to summation of I to 1 to n. That is I, where I stands for number of applications. Okay, so spec of I and to the whole power 1 by n, where n is equals to number of programs in the suit. Well understood, like from the number of applications available in the computer that will be tested, and the submission will be calculated, and the power of 1 by n, that is number of programs in the suite, will be